Hello, Ignacio. Would you like me to start now?
Yes, sorry, I was muted.
Oh, no worries. Okay, welcome everybody. My talk is on an aerial magnetometer survey that we conducted at Loch, Hawaii. We actually also did a ground penetrating radar survey, so we'll talk about both of those. Can we have the next slide, please? So site location for our project is on the west side of Pearl Harbor in an area called Loch. Next slide. So here's the site vicinity and layout. It's a 102-acre project site, 28 megawatts DC photovoltaic system. Next slide. So project objectives were to do standard environmental due diligence, phase 1 ESA, prior to executing a long-term lease with the Navy. We were looking at pesticides related to former ag use, an inactive 8-inch diameter buried JP5 fuel pipeline, UXOs associated with the 1944 munitions explosion at Waipio Peninsula, approximately a mile northeast of the site, and then other waste disposed and discarded at the site. And then also we conducted a phase 2 ESA to document baseline conditions prior to the execution of a lease from the Navy and construction of the PV system. Our consultants on the project were North Shore Consultants. They did the phase 1 ESA, Element Environmental did the phase 2 ESA. And then we had another consultant, Dudek, that did the geophysical surveys for us. Next slide, please. So unexploded ordnance is of particular interest to this project location. That munitions accident that occurred in 1944 at some landing ship tanks moored at Waipio Peninsula that were staged there preparing for an attack on Saipan. There was a sudden explosion on one of the LSTs and it caused a chain reaction. There were a lot of casualties and a lot of munitions related projectiles were scattered throughout the Loch area. Next slide, please. So this slide just shows the location of the LST explosion relative to our project site. Next slide. Here are some photos taken at the time of the explosions and right afterwards. Next slide, please. So our magnetometer survey was conducted using an aerial DJI 600 unmanned aircraft system, GEM systems, magnetometer sensor, and base station, and then some accompanying equipment. And that survey was conducted by AeroVision under subcontract to Dudek. Dudek was the prime for us on this project. Next slide. Here's a photograph of, couple photographs of the drone and the magnetometer. Next slide. And a short video.
A new way to detect metal underground. Still ahead on Island News at 5. How new technology is helping Hawaiian Electric build a new solar facility at Joint Base Pearl Harbor Hickam. But back here in the islands, drones being used to survey land at Joint Base Pearl Harbor Hickam. Hawaiian Electric Company using a drone to
we had a little technical difficulty on the
a new way to detect.
We'll pick up the video later. I'll try
Sounds
to
like a plan.
tee that up. Yeah.
Okay.
Metal.
Thank you. Okay, so looking at our magnetometer survey results, we see on the right-hand side a color contour map that shows the magnetic anomalies and our abandoned underground JP5 pipeline that was a particular feature of concern. We wanted to know where the location of that pipeline was, so when we started driving piles for a PV racking system, we wouldn't drive the piles into that pipeline. It had been cleaned and inerted, but still we did not want to impact that pipeline. Next slide. So Here's a photo on the left and aerial photograph on the left, and then on the right-hand side is a berm that showed up as one of our significant magnetic anomalies on the site, intersected by a road. Next slide. So we also had some other large nonlinear anomalies that were in both the west and east sides of the grid, and you can see those in the two photos. Next slide. There were a total of 37 small nonlinear anomalies that were identified during the aerial survey, and we selected 3 of those based on the strength of the signals to do a ground-based, ground-penetrating radar survey. Next slide. So this is a photograph of the GPR survey equipment that Dudek Environmental used, and on the right-hand side is one of our anomalies identified from the aerial survey. It turned out to be discarded tires that have steel belts in them that provides a magnetic anomaly when you do a magnetometer survey. There was also some other metallic waste like a discarded bicycle and a bowling ball and some other debris that was there. This also turned out to be the location of one of the projectiles, UXOs, but we didn't discover that until our construction activities. Next slide. So this site map shows the abandoned underground JP5 pipeline in relation to our site. It kind of cuts across that northwest portion of the site. Next slide. This shows several images that show the results of the GPR survey. We actually got kind of conflicting information between the aerial magnetometer survey and the GPR survey. So to be conservative, we went ahead and staked out the locations of both sets of geophysical signatures in the field so that we could avoid those locations during driving in the piles for the PV racking system. Next slide, please. So some other magnetic anomalies. Number 31, coral and limestone outcrop. Anomaly 16 was a metal pipe associated with an irrigation valve. Next slide. This is just a panorama of the anomaly 31 area showing the high grass that makes it kind of difficult to push the GPR equipment around. Next slide. Some surface metal debris that corresponded to the anomaly 7 location. Next slide. So in summary, our aerial magnetometer survey didn't require costly or disruptive clearing of the site vegetation. And of particular concern at the site, when you disturb vegetation, there's the coconut borer beetle that is of concern. It's in the site vicinity, so when you cut vegetation, it has to be removed immediately within a day of when it's cut. So this really saved us a lot of work for this preliminary site survey by not having to cut down that vegetation. The survey was completed in 3 days versus approximately 30 days that would have been required for a ground level survey, and about a third of the cost. So it was a big cost and time saving method. We identified some large linear and non-linear anomalies and quite a few small non-linear anomalies that were subsequently investigated visually and with GPR at selected locations. The aerial magnetometer survey and GPR results were both used to identify and stake out the alignment of the JP5 pipeline so it could be avoided during construction. And several of the anomalies were associated with solid waste, such as tires and metal debris, a couple of crushed drums, but only one anomaly, number 34, in the extreme northwest portion of the site appeared to correspond with UXOs. And that UXO wasn't found until during construction of our substation. Baseline soil and groundwater conditions were documented during a phase 2 ESA. So that kind of completed our environmental due diligence prior to executing a long-term lease with the Navy. And the PV system was dedicated and brought online in November 2019. Next slide, please. So UXO procedures we followed was the recognize, retrieve, and report. We reported 2 UXO discoveries to HPD via 911, and the Navy was notified as well. Next slide. So this is a 50 caliber round that we found very close to the start of our construction activities for the racking system. Next slide. In comparison, here's a much larger MK1 3-inch projectile that we encountered in November 2018 in the vicinity of our proposed substation. Again, that's in the northwest portion of the site near anomaly 34. Next slide. Just another view of that particular projectile. Next slide. And the approximate location where that was identified, that anomaly 34 near the discarded tires. And it just goes to show that in retrospect, we should have moved those tires after we completed our survey in and around there, and then gone back over that same area. We may have found the projectile at that time, but we did eventually find it during construction. And fortunately, there were no detonations. And here's just an aerial photograph from June 2019 of the completed PV array. So it's over 80,000 PV panels, about 300 watts each. So quite a large number of panels were required to construct this project. Okay, here's the video.
A new way to detect metal underground. Still ahead on Island News at 5. How new technology is helping Hawaiian Electric build a new solar facility at Joint Base Pearl Harbor Hickam. But back here in the islands, drones being used to survey land at Joint Base Pearl Harbor Hickam. Hawaiian Electric Company using a drone to detect metal objects, including steel drums and unexploded ordnance underground. HECO wants to clear the area to build a 20-megawatt solar energy facility at the base's West Loch Annex. Scientists say the drone is an alternative way to detect metal in the ground without having to dig.
Usually we have to use manpower to push equipment, and when you do that, it takes a lot of time. This particular site is very rocky. There's a lot of tall grass, so it makes it really hard to do that. We'd have to clear the whole site before somebody would be able to come out and do that kind of survey.
HECO hopes to start construction on its solar energy facility in January.
So, Dave, can you hear me?
Yes.
So a couple of questions here. How deep can you go with these magnetometer?
So we flew at an altitude of about 30 feet across the site. This is about 85 miles of flight lines. And it was kind of complicated because we're in the flight approach path for Honolulu International Airport. So there was a lot of pre-work that needed to be done. But to get specifically to your question, we thought that we were getting down to a depth of maybe 1 to 3 feet, somewhere in that vicinity.
All right. And let's see, one other question. Actually, also for the Guam folks, have you ever tried robots? Are robots a possible tool? Hello, can you hear me? Hello? I guess I lost you.
I'm still here.
Yeah, can you hear me now?
I can hear you, Ignacio.
Yeah, have you ever tried robots, like, the
So
wheeled robots? Yeah.
So we have not, but I'm fairly certain that the UXO crews, they do utilize those.
All right. Well, Well, thank you, David. And so we're running over, but I think we kept our technical information loose because there's a lot of information there. A lot of the information